It's been a wonderful discovery.
Good evening, everyone. My name is John Tiggs, and I'm the event coordinator here at McNally Robinson Booksellers. Before we begin, I would like to acknowledge that we are in Treaty 1 territory, and the land on which we gather is the traditional territory of Anishinaabe, Innuak, Anishinaabe, Dakota, and Dene peoples, the homeland of the Métis Nation. In addition, of course, McNally Robinson Booksellers itself rests on land once occupied by the Métis community of Roostertown. We are gathered here today to celebrate the Winnipeg launch of Cosmic Wonder, Our Place in the Epic Story of the Universe by Nathan Hellner-Mestelman. You may applaud. We're so grateful to Leith Publishing for publishing this volume and for their assistance in timing this evening. Following the formal part of tonight's program, the presentation from up here, there will be an opportunity to ask questions. If you do have a question and you're somewhere here in this space, just put up your hand and I'll run to you with this microphone, which is not a comment on your ability to project your voice. It just ensures that those watching at home can hear the questions. I'll be back at the end of the event to review signing procedure. Just a few quick introductory notes about our author. It's always a genuine pleasure to introduce an author at the very start of their career, particularly when said author is already as accomplished as our guest tonight. Nathan Hellner-Mestelman's Cosmic Wonder, Our Place in the Epic Story of the Universe, covers the absurd speeds of our tiny planet to the depths of the universe, and is a guide that offers a funny, deep, and insightful exploration. Nathan Hellner-Mestelman is an avid writer and science communicator, a contributor to Skies Up and the former Sky News magazine. He is a member of the Royal Astronomical Society of Canada and has outreach at the Dominion Astrophysical Observatory. His work has been featured in the Lonely Planet anthology, Physics World magazine, and Math Horizons, and his recent award-winning film, Universe vs. You, has been screened at film festivals internationally. He lives in Victoria, BC, but is here with us tonight. Please give him a very warm welcome.
Thank you so much. I'm so excited to be here. A huge thanks to McNally Robinson for having me, and a big thanks to John Tiggs in particular, who is nestled behind this backdrop. Yeah, so I hope there's great feedback on the book and not too much feedback on the microphone. And so this story, I guess, it began around 14 billion years after the Big Bang, on a small blue planet called Earth, and I was in grade 5, and we had just written some science project, and I remember one of my friends coming up to me and saying, "I hate science," and I was a little bit surprised at this because I love science, and I couldn't really imagine a reason why anyone would hate it. So I just kind of thought, Nathan, that's because you're a nerd. But I didn't quite limit my thought to that. I also wondered, is the reason that my friend hates science actually because they hate science in and of itself, or is it more the dry academic tone that it's usually served up on a platter on? Is there another way we can do this? Because science is not just words on a textbook, it's a thrilling experience that we are living out every day of our lives and continue to live out long after we're dead, because science, it's part of the entire life and death process too. But this book in particular, the idea that sparked it kind of began a few years later in that 14 billion year long story of the universe when I was, when would I be, 11 years old or so? It was in 2019. So this was during a total lunar eclipse. And I'd seen a few of these before. Basically, the moon was passing into the shadow of the Earth, and the Earth was blocking out the sun compared to the moon. And so the moon was going this beautiful blood red color, and it was so ordinary until around 11 in the afternoon. Sorry, 11 at night. You won't ever see a lunar eclipse at 11 in the afternoon. But around 11 at night, I was stationed at my telescope across the street from my house with a friend of mine, and we were watching the moon, and I decided that I was hungry. So I took my eye away from the telescope and I was like, all right, I'm gonna go get some cookies. 1 penny. And my friend was like, sure. So I step away from my post at the telescope. My friend starts looking through the moon, through the telescope. And in that 1 minute that I'm not looking at the moon, going to get cookies, I'm like, I've turned my back and I've started to waltz towards the house to grab the cookies. And my friend turns around and says, whoa, did you see that? No. I was about to eat a cookie. But it turns out what my friend had seen was a tiny flash on the moon's surface, really small, like kind of like a dying firefly. And what he had actually seen was an asteroid impacting the moon's surface. It was actually all across news headlines across the world the next morning. I hadn't really thought much of it. I hadn't seen it. But it turns out that this asteroid had been about the size of a small house and had blown a crater about as big as this bookstore, releasing the energy of about 50,000 kilograms of TNT in the process. And so I kind of thought at this point, if that had hit the Earth, it would have leveled an appreciable fraction of a city block. We kind of would have heard about this, but because it hit the moon instead, only a few hundred people on Earth saw it. It was a tiny flash. And I missed it because I was eating a cookie. But it just made me realize how much is happening out there across the universe while we're eating our cookies here on Earth. And to get you into that mindset of cosmic wonder, of the sheer preposterous size of our universe, I think yoga is the answer. So let's take like a 6-second breath, 3 seconds in, 3 seconds out. And in those 6 seconds, around 125 million planets were destroyed across the universe, accompanied by about 300,000 new stars being born. And that is just kind of the absurd nature of the universe we live in. We have this cordial blue blanket called the sky that girdles over our heads and lets us pretend that infinity doesn't exist, when in fact it is ticking along like clockwork every second of our lives, and we just have the luxury of having a layer of oxygen in between. But if we take that layer away and just ponder it for a moment, the story I want to tell you tonight consists of 3 parts, with maybe a twinge of a 4th if I have time. First, it's where are we? In the most abstract sense possible. I know where we are, I'm pretty sure we're at McNally Robinson bookstore, but in the bigger sense. And then followed by where do we come from? And then where are we going? And maybe if we have time, are we alone? I see you guys, I'm pretty confident that we're not, but I mean in the bigger picture. But to start, just where are we? It is my goal that by the end of this talk, we will have successfully failed to answer that question. Basically, it's a really hard question to even start to answer because our planet is rotating at around 300 meters per second. So every second that ticks by, we are being hurled along at about the speed of sound. And to add to that, the Earth is also moving around the sun at roughly 100 times that speed, so 30 kilometers per second. And then the sun is moving around the Milky Way at an additional 6 times that speed, so about 180 kilometers a second. And then the Milky Way is drifting through the universe at another 3 times that speed, around 600 kilometers a second. And when you add it all up, our planet is moving so fast that by the time you have finished brushing your teeth at night, the Earth has already moved about 3 Earths through the universe. And this is a real shame, because if Aeroplan or all those air miles companies listed your air miles based on the number of miles you had actually traveled, not the number of miles you've just girdled around the Earth's surface, you would be earning a free trip to Paris every 15 freaking seconds. But alas, it doth not work that way. But where are we in the universe? Well, I think to answer or fail to answer that question, we need to talk about the fastest thing in the universe, which is a sort of compass to let us chart where we are. And that is the speed of light, which is so fast if you were to joyride on a light beam, you could take a smooth cruise to the moon and back in just 3 seconds. It is the ultimate airline. And it kind of fails. amidst the vastness of the universe, you keep going beyond the moon, and it takes 2 minutes to reach Mars, and then it takes about 45 minutes to reach Jupiter, then 5 hours to reach Pluto, still love you, Pluto, and then about 4 years to reach the nearest star. And something interesting happens when you start talking about absurd distances where it takes light years to get there. Light is a bit like sound. In that it travels in waves, and waves can only travel at a finite speed. Sound is about 1 million times slower than light. It sucks, but it kind of serves as a good analogy. So if I say something and it comes out of the speakers like, buy the book, and you will actually hear that phrase around 1/100th of a second or so after I've actually said it, because there's a slight delay between when it comes out of the speakers and when that pressure wave of air actually reaches your eardrum and you hear it. So for all you care, I might have said, buy the book 1/100th of a second in the past, because it takes like a certain delay to reach you. Similarly, for light, if I were to do something like waggle the book in a very advertising manner, you would actually see me do that about 10 billionths of a second after I actually did it, because there's a certain delay between when the light actually leaves the book and when you see it. That's basically instant for us here on Earth, but if you're talking about Pluto, it's 5 hours. So anything that happens on Earth kind of happens 5 hours in the past compared to where you are in Pluto. Sorry, I'm just gonna have some dihydrogen monoxide. And when you're talking about stars, the nearest star is 4 light years away, which means it takes 4 years for anything that happens here on Earth to reach this star, which is called Proxima Centauri. And that means anything that happens on Earth, you'll only see it 4 years in the future. So if you are standing on that distant star, you'll see Earth as it looked 4 years in the past, because only then is that light from 2020 actually reaching that star. That means if you actually stood around that distant star and looked back on Earth 4 years in the past, you would just be beginning to see a very mild, small inconvenience begin to plague our society in real time, because for all you know, that is your now. Head out a little bit further to the edge of the galaxy, that's like 100,000 times further, and you're actually 100,000 light years away from the Earth. That means it's taken 100 millennia for any light that you're seeing out there to have crossed that distance. You look back on Earth, human civilization doesn't even exist yet. Let me try to put this in perspective. Light is so slow. If we make this whole store the size of our Milky Way galaxy, then all the radio we've ever blasted into the galaxy has formed a bubble about the size of the head of this microphone. And all the light that human civilization has ever produced is about as wide as my arms. So all the light that you've ever produced over your lifespan fits into a size of a cat's eye marble, I would say. And our Milky Way is just one of a few dozen galaxies in the local group of galaxies. The local group is about 10 million light years across. Something about astronomers and their obsession with the word local, long after it's lost any hint of recognition in our minds. When I think of local, I think of like my next door neighbors. Astronomers think of something that is 100 quintillion kilometers away. They're just working on an entirely different level. And the local group is one of about 100 groups in this thing called the Laniakea supercluster, which is just one of about 10 million superclusters in our observable universe. And that is about 46 billion light years out to the edge. It forms like this bubble of light around us. But the observable universe is not the edge. It's just an optical illusion. Because remember how the further in space you go, the further back in time you're looking? Well, you go far enough into space and you kind of run out of time to go back on, because in this whole 13.8 billion year long history of the universe, you can only look so far back before you run out of past. And that kind of forms a barrier that is about 46 billion light years on either end. But there's stuff beyond it. It's just that in the entire history of the universe, there has not been enough time for its light to have reached us yet. In fact, current theories predict that the universe itself is infinite, meaning that kind of like a Siri GPS on an infinitely large map, any hint of trying to explain where you actually are in the universe is pointless. So we have failed to answer question number 1, where are we? Next, we will fail to answer the second question, which is, where did we come from? And to begin to fail to answer this question, I think it's important to address a very common question that was asked by me when I was in middle school and a lot of my classmates. And this question is, where do babies come from? And the astronomer would say the Big Bang, and the parents would say the Big Bang. But to really answer this question in depth, we need to talk about where have our atoms actually been. Little thought experiment, take every atom in your body, kind of like put a tracker on it, and then we just dial back the clock. And we see where those atoms have been in the past. Go 7 years into the past, and it is likely that not a single atom that is currently part of your body was part of your body back then. I assume the 7+-year-olds are by and large here tonight. If you are over 7, chances are you have, for some portion of your life, been composed of entirely different matter. Not a single atom you're currently made of. Those atoms were scattered throughout the atmosphere, throughout the environment. And if you trace it back even further, chances are every bit of oxygen, nitrogen, carbon has probably been cycled through some sort of bacterium, because not only do plants, which produce the oxygen we breathe, need nitrogen-fixing bacteria that kind of eat the nitrogen and then break its bonds so the plants can grow. Chances are any nitrogen in your body has been through at least one of those bacterial cycles, but all the oxygen in the atmosphere was kind of burped out by cyanobacteria. It's like this really funky kind of bacteria that kind of just produces oxygen. The reason the sky is blue, the reason that we have oxygen in our atmosphere in the first place is because around 2.4 billion years ago, this kind of parasite started growing on Earth, and completely ruined the nice blend of methane and carbon dioxide and ammonia we had decorating our beautiful orange skies back then, and instead filled it with oxygen, which killed most life back then, and instead gave rise to we oxygen-breathing creatures, no guilt whatsoever. But yeah, every breath you take is cyanobacteria burp. And there's a really neat coincidence also, if you get into the statistics of it, that there's about 10 to the power of 22 molecules of air in every breath you take. That's an absurdly huge amount. But there's about 10 to the power of 22 breaths in the atmosphere too, which means that statistically, there's about 1 atom in every breath you take that has been breathed by every breath that has ever been taken throughout history. So every breath that I take, every breath that you take has 1 atom from Caesar's last breath, 1 atom from Shakespeare as he ate spaghetti on a November 13th afternoon, and 1 atom from, I don't know, insert whatever you want. It's probably there. And then you dial back the clocks even further, and you'll find that all of your atoms were once collected in this giant hot cloud of plasma that formed the solar system. And you might wonder, where do these atoms actually come from? Well, the Big Bang did create the universe, but it wasn't very good at it. It only produced 2 elements called, and you of course do know these, hydrogen and helium. And we know that there's kind of a bit more than that these days, I think. Like there's oxygen in the atmosphere, there's iron in the metal. And how did those come about? Well, when matter clumps together and it gets dense enough to kind of crunch down into stars, those stars burn so hot that they kind of take hydrogen and helium and smash them together into all the heavier elements that we see around us. The oxygen, the nitrogen, the carbon, those were all cooked up in stars. And the heavier stuff like gold, platinum, uranium, those were formed as those stars collapsed and blew up, which was about 1 trillion times hotter than the actual stars themselves. So you need like a little bit of a blast furnace to cook carbon, oxygen, nitrogen, and then you really crank up the heat in what's called a supernova explosion, and then you get all the other elements in the universe. So everything around you that isn't hydrogen and helium was cooked in a star. Probably more than one actually, because stars blow up and then they collapse into new stars, which blow up, which then collapse into new stars. But if you go far enough back, you can actually trace every bit of matter in all of our bodies to just a few particles that appeared right after the Big Bang. And it kind of sculpted our universe. Like when the universe was small enough to hold in the palm of your hand, these tiny little particles appeared and they left little dents like fingerprints in this little ball. And then that little ball grew to the size of entire galaxies and became as big as our universe today. But those little fingerprints were stretched along with it. So it kind of guided all the patterns and the formation of galaxies that we see today. It's like if you shrunk the Earth down to the size of the palm of your hand and then you left little fingerprints in it, and then you inflated it to the size of the Earth, all the oceans would kind of flow into those fingerprint areas. It's not that my hands can produce an entire ocean, but they can poke holes in a tiny ball that then, when inflated to the size of the Earth, can produce an entire ocean. And that's what happened right after the universe was born. These tiny subatomic particles laid the foundation for everything, basically. And that is where babies come from. But to really finish failing answering this question is what happened before the Big Bang? And to that, I would say, nobody knows actually. There's one theory that maybe it was the catastrophic collapse of another universe that kind of like a bad bounce on a trampoline rebounded and gave birth to our own universe. No guilt whatsoever. Whoever was living in that past universe. Then there's a lot of other theories, but I won't get into them because they're in here. And the third question, where are we going? Short answer, nothing good. Long answer, let's see. The idea of an apocalypse is certainly nothing new in our cultures. If you added up all the doomsdays and all the world's major religions combined, the Earth was kind of scheduled to end about 200 times by now. If you've seen the latest climate trends, we're working on it. I'm kidding. But basically, our planet has been theorized to end many times throughout our history, but the universe itself has been scientifically proven to be on a doomsday clock. And there's about 4 ways this could happen. It all has to do with a cosmic battle between 2 forces. One, gravity, which pulls stuff together. The other is like the counterbalance arch enemy to gravity. It's called dark energy, and it pushes things apart. It's pushing everything in space apart. It seems to just be a part of space itself. Space loves to expand and get away from itself, like a socially anxious teenager. And when space does this, it pulls apart anything that was pulled together by gravity. The real question is, which force will win? Will gravity pull stuff together? Will dark energy push stuff apart? Or will they just balance out? Or the fourth option, which is kind of a surprise. Not a joyous one, but the first option, let's suppose that gravity wins. And in that case, everything gets pulled together. Dark energy does not succeed in pushing stuff apart, and gravity ends up pulling the whole universe together into this nice warm hug that kind of isn't so nice. It kind of collapses everything into a black hole. So first the galaxies merge, then the stars collide, and then all matter gets crunched down into a single point, which, if you look at it closely, kind of looks like a reverse of the Big Bang, which is why there's that theory that maybe a collapse of another universe triggered the rebound of our own universe. There's the second not so nice option, that maybe dark energy wins and pushes everything apart. And in that case, everything that is currently held together by gravity will stop being held together by gravity at some point in the future, which is not great if you like being rooted to the surface of the Earth, which I generally enjoy. And what basically will end up happening in that scenario in about 20 billion years is first galaxies kind of start unspooling themselves, and then planets which orbit stars start to get drifted away, and then even planets which are held together by gravity will start crumbling like dry cookies and sort of dismantle themselves into a bunch of asteroids that then get ripped apart into molecules, which then get ripped into atoms, which get ripped into particles, which get ripped into nothingness, essentially, in which case we die, like really badly. But there's the third, more pleasant option. In fact, I want to get to the surprise before I get to the less devastating option. The surprise is something called vacuum decay, which is basically this hypothesis that the universe exists on these things called energy fields, and most of them are perfectly stable, but one of them is kind of just half stable. It's called the Higgs field, and it governs the entire universe. But if, for some reason, some little quantum wobble in this Higgs field were to knock it off of its half stable position, kind of like this book is stable on the shelf, but it obviously has a more stable position it could go to, which is the floor. And yes, I have the right to do that, but just suppose the book falls to the floor, it will release all its energy in a huge thud, except imagine that happening to an entire universe-sized field collapsing into a stable energy state. That kind of triggers an explosion the size of the universe, which is not great because it will trigger like this giant exploding bubble of plasma, which expands at the speed of light and kind of annihilates everything. And what makes it worse is that, you know what else expands at the speed of light? Light. So you won't actually be able to see it coming because the light that carries it will arrive at the same time that it arrives. So you'll only start to see it when it begins to contact your eye, at which point odds of escape are rather slim. But it's not going to happen anytime soon. Oh, that would have been so funny if it had happened right then. The last, more pleasant option is called heat death, which doesn't sound very pleasant. It's actually not. I don't know why I said it was more pleasant. But basically what happens is dark energy and gravity just balance it out. They call a truce, and space just expands at a uniform, calm speed forever. And I mean, stars still burn out, galaxies still go dark, but at least we have infinite time now. It's not going to be cut short by anything. And what ends up happening is eventually the sun begins to expand at the end of its life, probably growing so large that even the Earth in its far-flung orbit gets eaten up. So in about 5 billion years, if you plan to be on the Miami beaches, pack sunscreen, because you will not just be in the sunlight all day, you will be in the sun. About 100 trillion times farther in the future than that, something kind of nasty happens, or is theorized to happen, which is that protons, one of the basic building blocks of all matter, begin to fall apart, or they have a half-life, so to speak, which means all matter, basically, kind of like Avengers Endgame, no spoilers, starts to just dissolve into dust. And if you like your matter, which I personally do, this is essentially the end of the game. Fortunately, we are most likely not going to still be around by then. But if you fast forward about 100 trillion times further into the future than that, even black holes, which scientists thought for many decades were immortal, begin to fizzle away as they produce tiny little ticks of radiation that carry their mass off into the void. And after about, if you add a 1 and then 106 zeros, all the black holes will be gone, leaving nothing behind. So you can take that to be the official expiry date of our universe. I did a science fair project on this 2 years ago, and then I had to present it to kids. Because you present it to the judges, and then all the kids from like elementary school come in, and I'm like, oh, what a joy. I have to make them existentially paranoid. But then it dawned on me that these kids are just curious. Like, they don't carry the existential dread. That's our teenagers' job. So if it's just about the facts, like awe-inspiring facts, that's just what science is about. The existential dread comes later, but really the fact, we can frame this in a more positive light. You know what? Take the entire time span of all the stars, all the life, all the planets that will ever exist in our universe, and then compare that to that 1 in 106 zeros expiry date of our universe, and you'll find that we are here, alive, living, getting to appreciate this universe. In all life, we'll get to appreciate this universe for a span of time that is about 1 billion trillionth of the entire lifespan of our universe. And to me, that kind of frames the importance of appreciating the present moment, because we are in a cosmic golden age, and never again will the universe look as good as it does right now. And I'm so glad that I get to spend this cosmic golden age with you guys here tonight. So assuming that was optimistic enough, I would be happy to end this on a closing note. I don't know if we have time for the fourth story, which is Are We Alone? I mean, it's kind of been a question that's been pondered by philosophers and scientists and wannabe teenage couples since the dawn of times. Are we alone? But also just, are we alone? And the short answer is almost definitely not, because there are as many planets in the observable universe, in fact, about twice as many in the observable universe, as there are grains of sand on all the deserts and beaches on this planet combined. And when you add that up, it is preposterously unlikely that if life has begun to take hold on one planet in the universe, that it hasn't happened elsewhere. But until we discover life elsewhere, I just want to leave you on one closing note, which is you will often hear us astronomy enthusiasts and astronomers toss these kind of nihilistic remarks around, like the Earth is so insignificant, we are so insignificant, nothing matters. And I mean, right? But also, we can frame it like this. The Earth is the only planet we know of where thinking brains evolved. And when you think about it, there are billions and trillions of galaxies and planets out there. Yeah, we're pretty small, but also, until we find life there, we kind of have to assume that all those billions and trillions of planets and galaxies are going unseen, unheard, untouched by anyone, and are not being marveled at and experienced at. So, as far as we know, this planet is the only place in the entire universe where cosmic wonder happens, where we have a chance to actually experience this universe. We are the only part of the universe that we currently know of that can understand the universe. We're a tiny part of the universe contemplating itself, which is pretty meta, but also pretty awesome. So, as far as we know, we're the only place in the universe where brains evolved, where emotions like love and happiness and joy and awe happen. So, if I leave you on that note, hopefully you'll be able to sleep well tonight. And I'll leave you on that note. Thank you so much.
Now we do have time for questions. If anyone in the audience does have a question for Nathan, please feel free to put up your hand and I'll wander over to you with this microphone.
Hi, Nathan.
Hello.
So, what's your biggest hope for the impact of your book to change the world, if not the universe? I should have said change the Earth, if not the world.
I hope that it can give people what is known in psychology as the overview effect, which is something that was first reported by astronauts on the International Space Station. It's like this profound feeling of being above everything you've ever known and felt, and seeing it all kind of in one place. That's a bit abstract, I guess I should say. Seeing the world from space, to anyone who's seen it, I'm not one of those people, has had a profound effect where they just realize that all the lines we've drawn on this planet just simply don't exist. And they realize that the entire universe, 99% of it can be built with just 5 different elements. There's 118, the rest exist in small amounts, but most of the universe, the sun, the planets, us, are built with just 5. And there's that kind of oneness that comes with seeing the world and the universe that way. That's the kind of effects I want to give people, with a twinge of humor so we don't lose our minds. But there's kind of this thing that it's a very, very far-flung goal. But I think if we can give everyone on this planet just a little glimpse of the Earth from space, either by text or in person, I think that it would resolve so many of the squabbles we have on this planet today. There's like a little statistic I like to use that the world is currently pouring about $2.44 trillion into nuclear weapons development and arms development across the world. For about 5% of that cost, you could launch every politician and military leader on the planet. Whenever I say this, everyone always assumes that we're sending them off on a one-way trip. No. What I'm going to say is, you guys, to send them on a short orbital trip to space, just 200 kilometers up, and then they come back down, and parachutes deploy, just to show them firsthand the delicate marble they're dealing with. So this is sort of the first step, I guess. That's the perspective I want to share.
We know what gravity does, but what is gravity?
That question has kind of evolved a little bit over the last century. The Greeks thought it was because Earth attracts Earth, like elements and everything. And the reason you fell to your doom after you walked off a cliff was because you were made of Earth, and Earth is drawn to the Earth. But then in the 1600s, this frizzy-haired guy named Isaac Newton came along, and he realized that it's actually just mass that attracts mass. And then he couldn't actually explain why it happened. He just observed that it happened, that the same force that pulled that apple down from the tree was the force that kept the moon in orbit around the Earth. And then in 1905, along comes another frizzy-haired guy named Albert Einstein. There's something with frizzy-haired guys, I don't know. Albert Einstein then develops the theory of relativity, which states that it's not actually a force that's pulling stuff together. It's a curvature in the universe itself, kind of like marbles spiraling down a drain or things welling up on a trampoline, like in the dimple in the middle. And it's just kind of following the curves in space-time itself. And there, I'm sure, are more advancements that have slipped my mind at the moment, but I guess that's more or less what gravity is to our current knowledge, to my current knowledge.
Hi, Nathan. So would you like to be an astronaut?
If I were given the opportunity, like, hell yes, I would love to be. But anything really in relation to the universe will suffice for me. But if I could get to experience it firsthand off this planet, that would be fantastic. So sure.
Nathan, what was your process of accumulating all this philosophy and science to present this coherent perspective? When did that start, and how old are you now, just out of curiosity?
Well, right now I'm 17, and I suppose the process kind of began with first the comment that my friend hates science, and also the lunar eclipse, crazy size of the universe realization. But it's also just been this sort of lifelong sense that I am a tiny little bit of oxygen and nitrogen and carbon that just happens to flutter together. And I won't be around for very long, but while I'm here, I might as well try to figure out where the heck we are, where the heck I am. And the other part, which is, if you're gonna figure this stuff out, what's it all for if not to share? Because I guess you could take the solipsism approach but I won't get into that.
What were the sources of your knowledge?
Well, they have this fantastic place on the internet called the ARXIV, the archive, where they publish scientific papers for free, even though those same scientific papers are put in monetary journals like Nature, and nobody seems to notice, and nobody seems to have a problem with it either. But however that comes about, it's great, because there's this planet's worth of knowledge at your fingertips, and I guess just spending late evenings poring through that fascinated me.
And any other questions? All right. Well, if there are no other questions from the crowd, Nathan, if you have any closing comments, I can then let people know how to get books signed.
I don't think I have much else to say in the present moment. I hope I'll say more in the future.
Well, thank you so very much. That was a fascinating presentation. Thank you all for your questions as well. We will move along to the signing portion of the evening, so we will relocate Nathan over to this table, just to his right, where he'll be signing copies of the book. I will restock the books as well, so the piles will loom a little more precariously. Please do feel free to come up and have a copy of the book signed before you pay for it at the cash desk. Just please do remember to pay for the book before you physically leave the store. We're enormously grateful to Linda Leith for, of course, publishing this book and making this evening a possibility. The book is Cosmic Wonder. The author is Nathan Hellner-Mestelman. Please give him a very warm round of applause. Thank you all for coming.
Thank you so much. Oh, a word to the nerds out there. Take pride in it. Reclaim the word. Be proud to be a nerd.